Time for another video regarding my Thump Wagon build. The van we got over there. Enclosures in, enclosures built, drivers are in, and that's as far as this build is gone right now. Is the wall sufficient? No, I can already tell it isn't. Do I think it'll hold up for a little bit? Yeah, I do. So more or less that part of the build is done, and now we're going to focus on some other aspect of this build, and specifically the doors. They rattle the most, they give me the most problems, and I need to address them. I figured out how to get the driver's side window to roll up. There is a relay that is actually mounted down in the door that was bad, and it just so happened that I had some like universal relays that I just been holding on to for a long time, and it fit right into the forward plug, so window works, which means I kind of want to do another test and find out, because I think we can maybe do a baby hair trick with one door wide open and the other door closed. Maybe both doors closed, two windows down, we might be able to generate what is considered a normal hair trick. Although I admit we're still probably running at 50% excursion and somewhere between 50 and 100% of power potential. Back to the door. I really liked the initial idea of putting at first I thought a 12-inch driver, based on the amount of space there. That's closer to the OD of a 10-inch driver, and even that's pushing a little bit. There's some angles here dealing with that like vented corrugated. There's some problems with this design. The fatal flaw is that the motor assembly for the roll-up window falls right in this exact area. Other vehicles I've dealt with, it's over somewhere else, but that mechanism is right here, and I don't know how to get around that. I'm not ready to delete all of that stuff. I still want the windows to function, and so my first thought is that despite this being and I could maybe reverse mount a driver. I've seen it done, and you could just maybe flip that driver 180 degrees, let the magnet stick out, into the cabin area, and probably would work just fine. That is an option. I'm not against that entirely, and it kind of has an interesting aesthetic, so maybe. What I just noticed, having pulled this door panel off, is that looking at it, and maybe the back reflects a little bit more usefully, it is very close to the same dimension, the same plane. This perimeter here, all the way around, and this whole interior section is substantially different. I don't know, that it looks to me, when I'm looking at it, that's when I noticed the potential here. But if you flip it over, it's a very flimsy door panel, very flimsy, very cheap, very commercial vehicle like. So you can see this edge all the way around. That generates some pretty elaborate contours and shapes, but the perimeter outside of that, looking at it from the side, I'm not going to necessarily, I guess we can try and hold it. It is very similar. So this plane here, looking down that, is the same plane as this, and looks like the same plane. And if it's not the same plane, it's very similar. There is a bevel here, but the sharp edge is on the same plane all the way around. What that means to me is that I might be able to cut this center section away and only retain the very outside perimeter, which there are a few mounting locations to secure the door, but the majority of them are around the perimeter. So there's 1, 2, 3, and then there's 1, 2, 3, and again 1, 2, 3. So there's a total of what, nine screws that hold this door in place, this door panel in place, and then there's 2 for the actual door handle this goes on, and then there's screws that further secure this to the actual metal structure of the door. And there's a couple of clips internally. But if I remove this whole center section here, I might be able to take a piece of plywood, whether it's 1/2 inch or 3/4, depending on space availability, because I just don't know it's hard to tell exactly what gap we have. There's at least 1/2 inch where this guy sticks up, and there's easily, it looks like there might easily be 1 whole inch between, like if we remove that section. So this is far enough away from the metal, like maybe 1 inch. So I might be able to take a 3/4 inch sheet of plywood and then just extend it all the way out to here, and then secure from the back, or just secure the plastic together all the way around. And because this is a little bit of a chamfered edge, I might just be able to sand the wood, but I might be able to get a piece of plywood that covers that whole area, and then I have all of this real estate to mount drivers. And I think I have a solution for a door handle. So that square hole is for the actual door latching mechanism. But I believe I've got this guy. Sorry, I did not prepare this ahead of time. You can see that. It's just like a little stainless steel bar. It's very non-intrusive, very simple. But that could serve as a door handle. And that would be easy to locate in between drivers or something. And if we were able to start with a solid piece of plywood and secure it to this, because by the time we remove all this plastic exterior is going to be very fragile. But once you secure a piece of plywood to it properly, it might be more rigid than it currently is. And man, that's a ton of real estate. Like if that's a 10-inch driver, I could realistically secure 2 10-inch drivers. I could do something ridiculous like a 15-inch driver. I don't think I'll do that. I don't think I'll go more than a single 12. But depending on cost, like what I'll end up doing is I'm probably going to shop Parts Express until I find a smoke and deal somewhere else. But I'll probably shop Parts Express, which means I'll probably end up shopping Dayton Audio, because at a minimum, from Parts Express's plethora of manufacturer lineup, Dayton Audio has the widest variety of drivers at the best price. And I'll probably end up figuring out what is the best bang for the buck for the most driver for the value, and then what fits, like 2 10s, 1 12, just 15s. I'm not going to do a 15 in here. 4 8s, or maybe like 6.5s could potentially fit in this space here. It's likely to be something like 112 would be the best bang for your buck. Even 110 would probably be sufficient. And it just kind of depends on money. What makes a little bit of sense is if I was to configure this for 2 10s, when money comes in, I'll buy 110 and run 110, and I might poke both holes and then just put a cover plate and some little decal or sticker like vacancy or something. Try to be comedic, but eventually you could take the cover plate off and mount another driver and have 4 10s in here. I think that's what we're gonna do. I wanted to make a video of it because this was bothering me for a couple of days. I said, I have no idea how I'm gonna solve this problem. And I think that if we were to, how would this be the most logical? What I might be able to do is take some take some threaded rod, and put a nut on both ends and clamp that configuration to the door so that there's a threaded rod sticking out. And then we might be able to locate the holes properly so that when this door goes on, those threaded rods will stick out through the plywood door enclosure, and then I'd be able to put nuts on it and sort of lock the door panel more securely to the actual door itself, or something to that effect. Or I might be able to source some of those like crimp nuts that you like sort of rivet to a door panel or a piece of metal, and then they're threaded, and then you can run bolts in. So there's some options there, because even if I got this somewhat rigid, that plastic would still want to flex. And if I just had a plastic enclosure configuration, I can imagine some shaking and moving, and we want everything rigid. So I can imagine, I can envision ways with something like a threaded rod or bolts that go through that somehow secure to the inner steel workings of the door, to lock everything in place. And my limited experience with trying to sound deaden and get doors to sound good is, with money, you put a layer or two of sound deadener in the inside of the door. You fill it all up, and then I'll take like foam, like 1/2 inch or some fairly compressible foam, and just maybe spray adhesive it to whatever this ends up being, so that when we squish the door on, it compresses the foam between the metal frame of the door and this door panel. And then it's a bear typically under those conditions, but once you get it compressed and all the screws on and tight, then that takes up what slack would be there to allow for rattling. That's how I've kind of achieved this in the past. And I've only done it like once or twice. I don't have what I would consider a ton of experience at solving this problem. So that's what I'm thinking. Pretty sure the next thing I'm going to do is carve this section out, totally compromise this door panel, and cut me a piece of plywood as a foundation for this door. I've got to decide if we're going to make an enclosure that is sealed so that no sound pressure escapes into the interior portion of the door. That's a possibility, and that may end up, maybe we'll just do a 10-inch driver up here and then just use the rest of the space. So the way that this is raised up, I might build a little enclosure and then just have the driver sitting there, and then we can stuff it with polyfill, whatever it takes to get the highest level of acoustical properties. I'm expecting to run somewhere between 80 and 100 hertz high pass to this driver at some point when this all comes together, and that might be enough airspace to get a good acoustical response somewhere between 80 and 100 hertz. Preliminary testing, those sound cubed drivers have a pretty high QTS spec. Their Q factor is like a 0.605 or something, which gives them a punchiness. The bass note, like the kick drum note that they produce, is much more impactful and substantial than the Dayton Audio Ultimax driver, which has a much lower, I don't know, much lower, but it's like a 0.5 QTS spec. I think that what I've got is going to suffer on the low end because of how high the QTS value is. It's one of the reasons that it models with such a peaky resonant frequency, or it peaks really peaky at the tune frequency of the enclosure. I believe it's a direct result of the QTS spec. But because of financial restraints, we're going to run those drivers for a while. And because of how punchy they are, I will very likely not need a lot of mid-bass in my mid-range, which is good for clarity's sake here. I might be able to cross these as high as 120 hertz. And if that's the case, it should be easy to build some sort of enclosure to house a small, even though it's a 10-inch driver, the Dayton Audio, pro audio grade 10-inch drivers, they are not big, beefy things. They've got a fairly small magnet, and there's only 4 or 5 inches of depth to them, so it shouldn't be that hard to design something out of plywood that's easy. And based on what I'm looking at here, I think that this is actually going to be a pretty easy solution. Man, I was sure stressing this, but I think we got it. And so this is my brainstorming, and now we're going to start cutting it up and see where the shortcomings are in my thought process. Until next time, guys.